continue with lesson 3.2. It's more derivatives, more structures, and this is a radical structure which actually showed up on your homework. Sorry about that. My bad. I'm trying to fix it for next year, and I'm sure I said the same thing last year, so maybe some year before I retire I'll fix it. But f of x equals the square root of x minus 1. Find f prime of x. We're still using our f prime of x definition of derivative, which says limit as h is approaching 0 of f of x plus h minus f of x all over h. My key to doing this is I have to figure out f of x plus h looks like, because everything else is already there. F of x is a function, h is h. So if I go over here to my function and establish what f of x plus h would look like and simplify it as much as possible, I'm going to get the square root of x plus h minus 1. This x changes to an x plus h. That's all you do. You don't make separate radicals or anything weird like that. It's just one radical, x changed to x plus h. I can't make x plus h minus 1 any simpler inside the radical, and I can't take the square root of anything, so that's the simplest form of that expression. Next, if I apply the rule, our derivative f prime of x is going to equal f of x plus h, which is this stuff, minus f of x, which is the square root of x minus 1, and all that's over h. So that's job one in a problem this Friday. Using the definition derivative to find the first derivative is establish f of x plus h and then create the structure, and don't forget to put limit as h approaches 0. It's very forgettable, but it's part of the problem. And the definition itself doesn't allow us to put 0 in immediately because it has divided by h. So again, our goal every time is this h on the bottom. I want it to go away. So when you have a radical issue, radicals on top, and there's no cancellation of h possible, multiplication by the conjugate is the best fix. I'm going to multiply the top and the bottom both by the conjugate of the top, the square root of x plus h minus 1 plus the square root of x minus 1, remembering to change the sign of that, creating a difference of squares structure. Difference of squares multiplies by first times first and last times last. The outside and inside products cancel. So imagining FOIL. So if I do first times first, I'm simply going to get x plus h minus 1. Multiplying a radical times itself gets rid of the radical. All the signs inside the radical stay what they were. So the radical just disappears. When I do this times this, I'm going to get x minus 1. Now I want everybody to pay close attention to this. That says minus, and that says plus. So the overall sign of this product is negative, right? The product is a binomial. So make sure, that happens quite often in these problems, make sure that anytime the product ends up being a binomial in this situation, that binomial gets put in parentheses, or if it's a trinomial, whatever. If you're doing this type of multiplication and you're getting rid of a radical, and underneath the radical is more than one object, that whole thing goes in parentheses. I've noticed in some of your work that some of you guys are getting a little lax with parentheses. Don't need parentheses on that one because it's not being subtracted. The minus sign happens afterwards. On the bottom we have all the stuff we have on the bottom, which is h, and I'm going to keep h outside. I want h separated from everything else because I always want to get rid of h, so keep that away. Everything that's multiplied by it is just going to stay multiplied by it. So x plus h minus 1 under the radical plus the square root of x minus 1 under the radical. Now, if we look at the top of this thing, ideally what should happen is things in f of x plus h should be able to cancel with things in f of x to get rid of all the terms that don't have h's in them. That's what's supposed to happen. If that doesn't happen, you probably messed up somewhere. All right? So, this x and this minus x cancel, right? And this minus 1 and this plus 1, minus minus is plus, those cancel. And all I'm left with is h on top, right? Now this h is on top by itself, this h is being multiplied by all this stuff here. A part of a product and a single object are allowed to cancel. So one thing on top, one thing on bottom. H is allowed to cancel h, leaving me with 1 on top. What I'm left with on the bottom is all this stuff. So I get f prime of x equals limit as h approaches 0 of 1 over the square root of x plus h minus 1 plus the square root of x minus 1. At this point, the h all by itself is off the bottom. If I substitute 0 in for h at this point, I'm going to get x plus 0 minus 1 there, so I'm going to get 1 over the square root of x minus 1 plus the square root of x minus 1. This h changed to a 0, so basically it just went away. And adding radicals just gets me 2 of that thing. So my first derivative is 1 over 2 times the square root of x minus 1. Did it ask anything about domain in the homework?
Yeah.
Did it? Okay, so let's just take a look at our original function here, the domain. All right, x minus 1 is underneath the radical, and square roots, if we want to deal with real numbers, we're taking the square root of a positive number or 0. So in order to establish domain, x minus 1 must be greater than or equal to 0, which means x must be greater than or equal to 1. So if we write domain out correctly with the set builder notation, domain equals the set of all x's such that x is greater than or equal to 1. That's all that's happening here. Notice though in this answer, can x equal 1 in the answer?
Yeah.
If x equals 1, we're going to get divided by 0, right? So the domain of my derivative is the set of all x such that x is greater than 1. Okay, you'll find that sometimes at the very end point of functions, you might have an undefined situation because, again, this whole division thing going on in our definition sometimes creates problems that don't happen in the original function. What happens with this function at the very beginning is there's a dot at 1, 0. It'll be a dot, and then the graph goes up like this, right? That's a square root function, so 1 comma 0 is going to have a dot, and then it's going to kind of go up like that. This represents the derivative, which is the slope of any point on that line. And if I were to try and draw tangent lines anywhere along that line, there's just one tangent line, right? There's one tangent line there. At the end point, I've got this line that goes right through it once, that one goes through it once, this one goes through it once. There's infinity lines that can go through it once. They don't look tangent, but they're only touching one point, so they're tangent, theoretically. So that's what happens. So at the end point of a square root function, the domain is thrown out for that specific value. Everything beyond that, if you have 1.00001, there's only one tangent line there.
You want us to put the domain on it?
If it asks for domain, that's how to handle it. So if it asks for domain of the function, I'm looking for that. If it asks for domain of the derivative, I'm looking for that.
I think it asks for both.
If it asks for both, then that's the main reason they wanted you to tell. Polynomial functions are usually the same, but with radicals and rational functions, sometimes they're a little bit weird. So you got to kind of see some differences there. There it is. Found my